Okay, we are live. I've got chat open in case. Well, I guess we got chat open over here too. And I am going to start. No, recording was okay. We're good. I just need to start the show. Ready?
No.
Good.
You weren't prepared for that, were you?
I was.
Oh, well.
No, I wasn't. But I was going to start regardless.
I asked out of courtesy.
Yeah.
Not because I actually care whether or not you're ready.
Okay. Hey everyone, welcome back to another episode of theFnCall, a fun show all about web development. I've got Grant Glidewell on the show again with me today, as usual, gracing me with your presence.
Gliding into those DMs.
Gliding into those DMs.
We've come full circle.
Bringing it
How
back.
are you, Austin? Austin Gill, everyone.
Good. Yes, I'm Austin Gill. We do a show. It's fun. It's pretty okay. We do a pretty okay show about web development.
Okay. This is accurate.
You weren't expecting that, were you?
I wasn't, but I'm still tickled by it.
Okay. Cool. Well, do we have anything to catch up on? Did you want to do any sort of stuff before the show, or do we have kind of a lot to cover today?
I don't know. Like the stuff you're digging into, it's deep.
Okay. So yeah, we were talking on another show about planning on like what sort of topics we wanted to cover, and I mentioned that I've been doing a series of across different mediums all about like file uploads for the web, which I really, really like as a subject because on one hand, it's very ubiquitous. It applies across almost any application that you have files, you need to be able to manage them. You maybe want to be able to upload things to a web service. It looks at a lot of web primitives. So serving files, using forms, how to upload them, how to send them. And it basically goes across the whole stack. I mean, there's front end considerations, there's back end considerations, there's things across the network, there's things across infrastructure and how you organize your architecture. And it's a lot. So
it is.
yeah. So I guess I'll just kind of get started and walk through essentially a lot of the same content that I've been creating and will continue to create. So
okay.
Great.
I'm excited.
You have a web application.
I have that.
You have a web application and you want to allow people to upload files onto the web, right? What's the first thing that you need to do?
What kind of file do I want?
Probably doesn't matter. I generally think of like if you wanted to upload images, but it could be zip files or I don't know, whatever, really.
Text okay, will we cover why it doesn't matter later?
No, because I haven't, I don't I feel okay, already stumbling. Great.
I'm sorry. Okay, so when I think about file uploads, absolutely, like images is the first thing I think of because it's like ubiquitous. I have some sort of web app. I have a user. I want to change my avatar, and I don't want to grab it from Gravatar because for me that's just Captain Picard, and that's how I know that like a service has pulled my stuff from Gravatar. Is I have like embarrassed Picard.
Yeah, I do like Gravatar as a service.
Yeah.
Okay, so it feels like you had a deeper thought on like why are we already talking about limiting types of file uploads, or you just
in my mind it like I go immediately to like storing this and what that looks like, and I know we're going to get into that, like having just looked at the blurb, and so that's why I went to like, well, what kind of upload? So like,
okay,
maybe does it make sense for you to kind of follow end to end, like uploading just an image?
Yeah, we can go there. Okay, so I think I think the problem here was I'm talking to a senior developer that's like, okay, before we actually start coding,
I'm
let's get some
refining
business
requirements and
requirements.
making sure the
Yeah,
scope is small enough for me to.
I need to see like have we run this by yeah. No, but I okay, so take off the sort of uh architecture and planning and avoiding scope creep and avoiding technical debt hat. Let's say like you want to sit down and actually start coding and you want to allow user to upload a file to your server. Like what are the things that you need for that?
We need a field for them to put the file into, right?
Yes. So you need access to the file. And
Okay.
currently browsers, I'm like baiting questions that I know the answer to and you have no idea how to answer. So it's kind of rude, but I also don't want this to be me just talking at you the whole time.
Yeah.
But yes, you need essentially you need one of the things is access to a file. Now, technically, you can create virtual files in JavaScript, but that's if you already know what you sort of want, and you could, I guess, do that based off user interaction. But let's just assume you want a file off of the user's computer. In in order to do that in the browser today, you need user interaction, which requires an input field with a type of file, and that's how the user selects what file they want. And the reason for that has to do with security issues, and some of that may change in the future around the browser having access to very specific folders in the operating system that is not a user's folder necessarily, but like a temporary storage. But if you want a file that the user is selecting, they have to be able to select it through a file input.
Right. And this, for some reason, is bringing up for me, like, I think we discussed on a show a couple months back some security issue around allowing access to the camera, like some browser API around that. Anyway, more tangents we don't need to get into. But so yes, we need a file input. So we have this. It is input of type file.
Yeah. Okay. So you put an input type file on the page, and there you go. User is putting a file on the page or in the input. Next, you also need a way to actually send that file to the server. And assuming just HTML, like a progressive enhance approach, the way you create an HTTP request is
the form post. What?
A form. Yeah.
A form. Yes.
A form.
Yeah.
Yes.
I think this is probably where a lot of people's approach to like controlled forms in React, which is like bad. It's bad, but like, yeah. How do you take this input type and stick it into something like that? Like, I think that really would be difficult. I don't know. Yeah. Maybe it's super easy. I've never done it.
Okay. Well, just to keep things sort of going, you need, in order to send a file, you need to make an HTTP request. You need to be able to attach a body to the request because you can't send a file as in the URL. And you need to set the content type of that request to multi-part form data. And that's because that is the content type required to transfer binary information of the file, because otherwise you're sending data as either key value pairs or like a string or something. And you need actual access to the binary. In order to have access to the file on the server, you need to send that as binary in the request body. So all of this comes together in the form of an HTML form with a post method, with a method attribute set to post, the enc type attribute set to multi-part form data, and then you want an input field of type file. Now, of course, you also want a label and the name attribute on the input and the ID attribute on the input, and associate the label that way for accessibility reasons. And you want a button in order to actually submit the form. But that's basically the things. Four things that you need: a form to make an HTTP request, a post method attribute to have a body on the request, an enc type attribute to set the content type of the request, and the file input field.
And yes, exactly. So this does get actually really complicated if you have like control components. I have done this, and the multi-part ink type is what reminded me of that, because that becomes very, very difficult to do when you're like pulling the data from a ref. Anyway,
Yeah.
let the platform handle this for you.
Yeah, the platform has it built in.
Yep,
So
exactly.
let's do that. Okay, so now we've accomplished the client side of things, right? And then we say, okay, we want to actually progressively enhance this. Now we want to not just work in HTML, we want to work in JavaScript. So with JavaScript, to accomplish the same thing, you basically need to, let's say, use a fetch request. Maybe you construct the form body using a form data object. And once you use a form data object, that automatically sets the content type of the request to multi-part form data. So technically, you don't need to set that. You also need to set the request method to post. So let me start kind of from scratch. We say create a fetch request, fetch the URL where you want to submit the form. Maybe you grab that from the form's action. Do create a form data object using the event or using the form DOM node. And then set the body of the request to that form data object, set the method of the request to post, and then you don't need to worry about setting the content type, because that will the browser will automatically set that if you use a form data in the body of the request. And there's a whole bunch of other nuance around like writing code so that it's reusable across, get and post and multiple different forms and things that don't have content type or whatever. But that's like sort of the necessary requirements for the JavaScript world. Yeah.
Right.
Cool. Okay. So now we're actually sending the request, and whatever, it works in HTML and works in JavaScript. Now we want to jump over to the browser or the server side of things. And this is where things get really low level information, a lot of stuff that you don't actually need to understand. But, I'll try and bring it up to a ultimate solution or ultimately a solution that is like high level, and we're not recreating the wheel. Recreating the wheel.
Okay.
Gosh, when you say something and it doesn't sound right in your head?
Reinventing the wheel.
Reinventing the wheel.
I heard it and I'm like, no, that's about right. Reinventing the wheel. That's the one.
Well, I was reinventing the wheel with how you say that saying.
You're recreating the phrase reinventing the wheel.
Yes, I'm recreating. Too good. Okay. So hopefully, and hopefully that people listening, like, that's the mouth blogging is enough. I will have some content.
Mouth blogging is a disgusting phrase to hear in my ears.
Yeah. Mouth blogging.
You could sell that. Somebody's into that.
Yeah. Okay, so now we have the request, and things get kind of interesting on the Node side of things, because a lot of the times, if you want to, if you're working in Node, you're probably not working just in Node. You're using some sort of HTTP server framework to build your application, and most of these server frameworks provide some sort of higher level tool for processing data, like a data parser, right? Like Express data parser, or Fastify has not data parser, body parser. Mm-hmm. So Express has a body parser, and Fastify has a body parser, and all these tools.
Right.
But these are built on top of some primitives that are available in the actual Node request, what's called an incoming message. The request object that comes in on Node is called an incoming message. And what the incoming message has is a way to receive those requests. Now, the reason why I say that things get kind of low level is because requests don't get received all at once, especially when you're dealing with large payloads like files, because a file, consider a file that could be like 5 megabytes, right? If you have a Node server and it's running on 4 megabytes of RAM, you can't receive that entire request into memory. Otherwise, you've exhausted all of the resources of the RAM, right? So the way a Node server works, and the way that HTTP works, is the browser will send that request in little chunks of data at a time. These little bits of data are called chunks, and these chunks make up what's called a stream. You're familiar with streams?
The chunks are streamed.
The chunks are streamed, yes.
Cool.
And a stream is really hard to explain. It's really hard to understand. Like, it took me several times of working with streams to finally kind of understand it. But it's sort of like a conveyor belt where a chunk of data is like an object that gets put on the conveyor belt and it gets sent along. And at the point that it comes to you, you can like manipulate it and send it to and keep it going back on the conveyor belt along its way. And all along the conveyor belt, different processors can handle that chunk of data without necessarily receiving the entire collection of all of the chunks at once, right? Or I was listening to Wes Boss make a good example of this. It's like having a 30-foot long sandwich or sub that
you're just taking bites out of the middle of it.
Instead of having to eat the entire sandwich at once, you can actually cut it into multiple parts and like eat them as they arrive to you, right?
So like this is something that I get really baffled by, and this like leads into file types and how this handled. And like a lot of this is happening in Express middleware. And so like if this piece of middleware, this is what, like one of the processes on the conveyor belt that can deal with a chunk of data in a stream, would be like a piece of middleware. And so if I want to take some of this data and make it purple, for example, if it is a zip file. This is a very weird thing. Just go with me on it.
Sure.
All zip files purple. So purple zip file middleware sees this chunk. So like the chunk must have some sort of capsule that identifies what it is and how it connects to the rest of them. Like, how does chunk work? How do I know what's in my chunk?
I just keep saying chunk. It's starting to lose meaning. What's in my chunk?
What's in my chunk?
Yeah.
Well, we got streams of chunks, which is also gross. Disgusting. But
so I think what you're asking is probably a little bit beyond my deepest level of understanding. But I think like packets of data.
Can we assume it's on a header and just tell me
I think each chunk contains information about what it contains.
Okay.
Right. So it's not just
So like packets on a network work similarly, where they have like a base level of information about where it came from, where it's going, and then it has like information encapsulated in it. So it's
like Cotton Eye Joe.
Hey, where did you come from? Where did you go?
Yeah.
I still can't get over streams with chunks. Do we ever cross the streams?
I mean, I get that that's a joke, but
you never cross the stream. The only answer is you never cross the streams.
They do cross the streams at some point.
That's with the demon dogs, though.
Yeah.
Okay. That's true. Bad outcome.
In case of emergency. Okay. So getting back on track, right? So Node is receiving a request, and the request is being streamed one chunk of data at a time, and Node needs a way to process that data one chunk at a time. Now, if you have a regular a regular HTTP request that doesn't contain a file, it's not likely that it's going to consume all of the memory on the request. So what you can do is actually receive all of those chunks one thing at a time and store it all in memory and like put it together and recreate the entire request object or the body parser. You can parse the entire body in memory and do something with it safely. If that request contains files, which is likely a multi-part form data, then you run the risk of, or you don't want to stream the entire request body into memory. Okay.
Right. You don't want to risk that because you have constraints on the server.
Yes.
You
Yes.
you might run into something expensive. And so if the ultimate goal for that for the file that now consists of many chunks is for it to go to some sort of storage service, which I think we're going to get to next. One of the pieces of middleware could just restream that to like a chunk at a time. It could like
Yes. Yes.
siphon it off into some other
Yes.
service, right?
Yes. So get to that in a moment.
Okay.
Still, the underlying, like one other underlying principle is Node has a event listening system where it can listen to various events on a request. So you can do request.on and you can say on data. That's when you know that you're receiving a chunk of data. So on data, you can do something with it. And then on end, you know that you've received the last bit of data and you can do whatever. So you can create an array and listen to the on data event. And for each chunk of data that comes in, you can push it to an array. Now you've got an array of what are called buffers, or a buffer array. And on the end event, when the request has stopped receiving data, you can take that array of data and concatenate it and convert it to a string. And there you go. You have a body. You have a rudimentary body parser. Now, again, this array of buffers data is living in memory at this point, right? So far, we're still talking about a body parser, an in-memory body parser. And I mentioned the term buffers. Buffers are another one of these like nebulous words that like you're like, a buffer, like what? Yeah, I've been working out. Thanks for noticing, you know?
Okay.
That was all right? That was off the top of the noggin. So anyway, what a buffer is kind of weird, but JavaScript doesn't have a way for like handling binary data directly. So what a buffer is essentially it's a reserved space in memory for data, like usually binary data. And it's an object that JavaScript can deal with that represents this space in memory of binary data.
Gotcha.
Make sense?
Yeah.
Close enough? Okay. Also really kind of hard to explain and understand. Also okay if you're listening and you're like, I didn't quite get that. It's just memory allocated for binary data. That isn't like a variable.
It's something that has to be converted for it to be useful.
Yeah, but it's basically a way that we can use it. So we can assign something to a buffer so that we can actually use it in programming, but it doesn't, like we can't actually interact with the contents of the buffer directly in JavaScript. Right. Hopefully that makes sense. So now we've sort of discussed, okay, we're receiving data one chunk at a time. We're creating buffer arrays. We're turning that buffer into the body of the request, and we're doing all of that in memory. When we want to handle multi-part form data, and we say, well, we can't handle a file upload entirely in memory. We need to shift to a different sort of paradigm. And that's where we reintroduce the topic of streams. So we remember that information is streaming up. So the request has access to like streaming data coming in. So what we can actually do is create what's called, well, we can create a different type of stream. We can create a writable stream, which is essentially we're creating the stream and we are planning to write something to it. And this is going to be, a stream is essentially an asynchronous operation that is going to happen over a course of time across several different events. So all of those different events are like these chunks of data that we're going to put into the stream. So you can almost even think of it as a regular, like natural stream in nature. And over time, you're just going to throw in little paper boats, right?
Do not pollute your local streams, but I see what you're saying.
Yeah, don't pollute your local stream. Maybe you can, maybe throw in some leaves or something. Have you ever done like leaf races?
Yes.
Yeah.
Well,
like that.
Yeah. Okay.
Like that. And so each of those little leaves is going to represent a chunk of data that goes down the stream. And then later on, at some point, someone down the stream can actually do something to process each leaf as it comes in. Maybe it's take a photo of it. Maybe it's throw a rock at it. I don't know.
The rock throwing middleware is my favorite.
Yeah. Okay, so what we're going to do is we're going to decide to work with streams that are coming in, and we're going to take that and pipe it to our own write stream. Now, in Node, we have access to what's called the file system write stream. So you can say, hey Node.js, I want to write something to the file system. I want you to open up this stream that's going to write to a file at this path. And now we have the other bit of information that we need, which is going to be sort of the output for that data as it's coming, the request data as it's coming in. Okay. So instead of storing the entirety of the request object in memory, now we can just write it to that write stream, which is going to put that data onto disk into the file on the server.
Okay.
As that data comes in, that chunk comes in, it goes right into the write stream and gets processed to disk, and then it's out of memory. Okay, so we can just take as much, so we can take as much data as we want until either, let's say, the request times out or the entire disk space on the server runs out or something like that. You probably want to limit how large of a file you want to be able to accept.
Okay.
Right?
Where would I do that? So like where we've come from is we have like a form field on some in a browser. This form field has some sort of like post action in the form. It sends this. We're streaming our chunks, and those chunks become buffers. Purple. The purple buffers are then put onto a writable stream, which is now on disk instead of in memory. But we don't want to write too much to the disk, just like we don't want to fill up our memory. So where would I limit that?
So you could do that at the middleware level, or like at the tooling level. You could either inspect the request and see what the content size or content length is, and you can say, whoa, that's way too much data, just like deny the request.
Right.
But again, this is where now we've kind of reached the lowest level of the lowest depth of knowledge that I want to get into. And now I want to come back up to the surface and be like, let's not recreate idioms about reinventing wheels, right? Okay. So
my suspicion is that you can do this before it hits the server is where I'm going with that. Is that you could do this in a few different places, right?
So yeah, you could do it in JavaScript on the client, and you could like check the request for like basically intercept the request before it goes. You could check the size of the file before you create the request.
Yes, but you would have to do it through JavaScript. It doesn't look like HTML
you can't
currently
you can't do it in HTML. And
there's
once
not
again,
a max size attribute for an input.
No, and once again, you're talking about a request. You're talking about client-side validation, which is possible, but I don't think is reliable enough. So it's probably not where I would focus my attention.
Okay.
If you want to limit it, let's take a step up into the higher level concepts first. So we kind of talked about, requests coming in, streams of buffered data. Buffered data is being piped to a different stream that's going to write that information to the disk. That's the concept. The actual implementation is not worth making yourself, because other smart developers have spent a lot of time creating excellent tools that can actually receive. There's libraries that can receive a node request object or an incoming message, and can do all of that processing for you and give you even more tools that you would want. So the one that I've been using is called Formidable. It's pretty good. It's kind of old, but it's like well established, but old in that it uses callback based syntax, asynchronous syntax instead of promises. So really what I like to do is just like wrap a promise around it and didn't do all the processing that way. Cool.
This is the package Express Formidable?
No, that is the Express version. No, it's just Formidable.
Oh, just Formidable. Okay.
Yeah.
So but they do make an Express middleware.
Yes.
Okay.
Yes.
Okay.
And really like there's there's libraries for different frameworks that if you want to use, but I like Formidable because I like to work with the primitives of the runtime that I'm in. I like to know I always have access across whatever framework. If I'm working in Node, I can always, if I have access to the Node incoming message, I can use Formidable the same across any project, right?
Gotcha.
Okay, so now we get into beyond implementation details. We get into the next higher level of consideration, which is architectural decisions. So the problem with taking requests and writing them to disk is two that I've really considered. One is if you're building an application in a distributed architecture, then you can't really depend on a file coming in being received by a single server across a network of connected servers. If it's received by a single server and that file is being written to that server, it's really hard to track down where all of your files exist across the several servers in this distributed architecture, especially if you're talking about like serverless or edge compute or something like that. You don't even have access to those servers. That's ephemeral data. Number two is, let's say, even if you're not in a distributed infrastructure, you may be on a single server. And if we're talking about like Akamai's connected cloud VPS servers, smallest size, $5 a month VPS, you're going to get one CPU, I forget how many gigabytes of RAM, and 25 gigabytes of storage space. Now, if your application is receiving a lot of uploads to the point that you're going to exceed those 25 gigabytes of storage, you are going to have to upgrade your server. And upgrading a server for the sake of expanding storage seems wasteful to me because storage is actually really cheap. Now, if you want to upgrade because you want to increase the number of CPUs, or you want to upgrade because you want to increase the performance from, there's more RAM, great. But if I'm saying I'm receiving all these files and my server is running out of disk space, upgrading for that reason is a waste. So what you can do instead is use what's called object storage. So take that so let's say we in the scenario where we upgrade our server to get the next greater plan, and we don't do it for CPU or RAM reasons, we just need more disk space, it's going to cost us $10 a month, and that's going to get us 50 gigabytes of storage. So that's an additional $5 a month for an additional 25 gigabytes of disk.
Okay.
Right? Take that same $5, put in an object storage, you're going to get 250 gigabytes of storage. And in addition to that, you're going to get a single bucket to put all your files that works across a distributed infrastructure.
Right.
Because it's a single place.
Right. It's a service designed to do exactly what the goal of this is. Yeah.
Yes. Highly scalable, highly available, a lot of good things. That's what it's built for.
Right.
Okay, so if we want to do that, then you get into some weird. Any thoughts or questions so far?
So I'm curious, as we're writing. So we write this to our storage service. Like what is then returned to the client? Like I think that kind of depends on the storage service you would use, right?
Yeah, that's it. So that's a good question. So far, we've just decided that we're going to use object storage. We haven't actually done the work to incorporate it into our application, right?
Okay.
So there's a number of ways that you can do that. Most of the recommended ways that I've seen are to use what are called signed URLs. And this is kind of a weird interaction. Basically, the client would make a request to your backend. The backend would make a request to the object storage provider for a signed URL. the signed URL, which is basically, hey, I want a URL that anyone can upload to for a certain number of time. So like, let's say 15 seconds. And it's like obscured. It's like a hard to guess URL, right?
Okay.
Or let's say like 60 seconds, right? So it's valid for 60 seconds. So the object storage provider is going to return to you that signed URL to your backend. Backend returns it to the client. The client says, okay, now I have this URL that I can upload directly to, and you can upload a file from your client to bypass your backend and go directly to the object storage provider.
Oh, that's interesting.
Directly.
Okay.
Yeah.
Okay, so that completely negates the need for you to build a server. You're just building like a key hider front. That will return that.
You do need to serve. I mean, if you're just handling uploads, you still need the server to have access keys to make the request for a signed URL.
Right.
But
you could just have a Lambda to do that. It doesn't need.
Yes. Yeah, it could be like really a very simple thing.
Yeah.
Now, I don't personally love this approach because of the back and forth and the reliability, or the reliance on multiple requests from the client to the server, back to the object storage, back to the server, back to the client, and then from the client to the object storage, back to the client, right?
So I want to map those requests out real quick. Okay, so I have a form. I click upload. Upload does not actually upload anything.
Yeah.
Upload sends a request to I'm going to call it a Lambda because that's what I would put this on. Lambda says, hey, service, here's my key. Give me the 60-second valid or X second valid, heavily obfuscated like URL that this client can use. Sends that to the client. Then the client sends data
Does
there.
the real upload.
Yeah. Then I assume they are returned some URL where that file can be accessed.
Yeah, some metadata information.
Okay. Okay.
Yeah.
And then that goes to maybe another Lambda that writes it to some storage that I can reference later on their user object.
Yeah, that's the thing. I
see all this back and forth. I get your hesitation on that. That makes sense.
Yeah, and like, it doesn't have to be that way. You could assume that the client is going to be successful in uploading it. So the backend that originally requests the signed URL could automatically create the entry in the database where that file, like where the stored file is going to exist. Okay. Object storage URLs are very predictable, or they can be very predictable. Like, you can base it off file names and stuff like that. There's some decisions you have to make on whether you use a timestamp or not. Like, do you want files to be overwritable? If I upload a file with the same name, should that replace the previous version, or should it be timestamped or something like that? Right. Anyway, that's one version, and that's the version that I don't personally like because of all that.
I can see that. It's like super quick and dirty and would be very light to implement.
And that's what most people recommend, or that's how it seems that's how most of the content out there is written. The version that I like took a little bit of work to figure out, but it is doable. And that is that instead of doing a signed URL, you basically pipe the request stream. Instead of piping that request stream into a write stream, like on the file system, you pass that request, you pipe that stream into a readable stream that uploads directly to S3.
Okay.
And I'm going to skip all of the nuances around the challenges and where it kind of got tricky, because it was a learning process. But the actual understanding is, take this stream of data coming in and pipe it directly to an upload stream to S3.
Gotcha.
So it never touches disk on my server. Yeah, I mean, you could, if you wanted to, pipe that request, the file upload request, pipe it onto a write stream that writes to disk, and then you have the file on disk temporarily, and then you could read the file and pipe that to an upload to upload to S3 if you wanted to. Or I'm using S3 and object storage interchangeably.
Right. Because pretty much any object storage provider is going to be S3 compatible. Like that's a whole thing.
Yeah, and this is another thing. This is another topic worth explaining. S3 was originally a service created by Amazon. It stood for something something something. S3. Yeah.
Literally that. It's something something something.
Yeah.
That's three S's.
No. Yeah, it was three S's. I should probably look it up and know that. But essentially it was they originated this concept of these like static or file object buckets, and they called it S3. And then
simple storage service.
Simple storage service. Great. Something.
Yep. I like that better.
Yeah. And you have to like say it all like mumbly like that too. Like something.
Yeah. Highly technical.
Yeah. And so along with this service that they created, they also created their own standard or protocol for interacting with that service. And that became so popular that other service providers decided, hey, object storage is a great solution, but we don't want to recreate an idiom about reinventing the wheel ourselves. So we are going to we're going to make our own object storage service compatible with this syntax, this S3 protocol or standard. Which is nice because then what you can do is actually use libraries that were written and maintained by AWS, and you can use those and point them to your own object storage location, such as the Akamai Connected Cloud object storage that I was using, or I do use, right?
Gotcha.
Okay, cool. So now instead of writing to disk, I'm writing to object storage, which is saving me lots of money, and it's very resilient, and I don't have to worry about running out of disk space. And I can do this in a distributed architecture.
Yeah, and you don't have to run like a beefy server to do this. It can be done on free tier stuff.
Yeah. Cool. Yeah, I mean, you can basically start. It's interesting that the barriers to enterprise grade architecture is just coming down, and like the costs are getting really, really affordable. Okay, any questions or thoughts on it so far?
I wanted to disambiguate something. You have been using the term pipe. And I believe you just mean like send it to the next thing, because there is a proposal for a pipe operator.
Yes, good call.
You don't literally mean using the pipe operator, which is only stage 2.
Yeah, no,
I thought it'd be further along. I've been hearing about it for a long time, but you mean like mentally plummet over to this or that.
Yes and no. So when you're dealing with streams of data are funny because they're kind of hard to grasp at first, but then also everything related to them has something to do with water, or it's related to water. So they're
like a water balloon, hard to grasp, kind of funny.
Yes.
Okay.
Yes.
Streams are like water balloons.
Yeah.
Can a stream explode?
Probably, maybe. Yeah. So when I use the term pipe, it's an actual term related to streams, and that is if you think of a stream of data coming through like coming like a stream of a river, a pipe is like sticking a pipe in the river and rerouting where that water or where that data is going. So when I say I have a stream from a request and I want to do something with it, I want to send it somewhere, I can use a pipe to pipe it over to a different location.
Pipe is an event on a stream. According to node documentation, pipe is like an actual event on a writable stream.
Okay.
I don't know.
I believe.
Sorry.
I believe.
It's a thing. Not something that we need to dig further into, but I wanted to make sure that we're not thinking like we're using the node pipe operator.
Yeah. Basically, gotcha. I like to think of it as take this data and point it somewhere.
Gotcha.
Okay. So yeah, what we can do is essentially take the request object and send it over the uh, to the upload request to S3. And this gets kind of weird because then just a little more mouth blogging that is not going to be super uh, super coherent for listening to, so I'm just going to kind of gloss over it, is that with Formidable, to do this in a custom way, I'll just like read the blog when I post it or like watch the video or whatever. But essentially there's 3 types of streams. There's a readable stream. You know what? There may be more, but there's 3 main ones. There's a readable stream, which is something that you can essentially read the data from as it's coming in. There's a writable stream, which is you saying, I want to create something that eventually over time I'm going to push data into, and it's like I'm going to write it somewhere. And then there's what's called a pass-through stream, and that's basically both at the same time, where I can read from one source and then maybe do something with it, or you know what? There's a 4th one. There's a transform stream, but I'm not going to touch that one. So a pass-through stream is basically saying I'm going to be reading data from one place and then writing that data somewhere else.
Okay.
So what we do with a pass-through stream is connect both the request that's coming in and the request that we're sending to upload that information.
Okay.
It is the pipe that joins them. Make sense? Hopefully.
Yes. There's some stoner jokes there, but
yes.
Yeah.
Yes. Good one.
Pipe that joins them. Okay, cool. So that's like end to end. We've got like a user, and there is an upload page for their avatar. We have a server in the middle. We've got a storage service on the back. We know how to read and write these things, and cool.
Yeah. And we're almost full circle. Like we have gone actually one way of receiving allowing the user to upload the data, receiving the data on the back end, putting it somewhere in our architecture that is going to be cost effective and high availability and like distributed. And the one problem is that object storage deals with like static data, which can be updated, but is not like dynamic. It's not like dynamic on request.
Right.
Object storage is deployed to specific regions in the world. So now you say, well, I have this, and if now it makes sense to start talking about images, right? Because then we say, if the user uploads an image, I want them to be able to see that image in our application somewhere, which means I need to be able to point to it. And object storage is cool because you can make those uploads. They can have different ACL values or access control layer values. So you can have it be nothing in this bucket is accessible to public users. It's only uploads. Or I want people to be able to access them and be able to download them. And for images, that makes a little bit more sense, right?
Right. Everybody needs to see my embarrassed Picard.
Exactly.
Or disappointed.
Yeah. So now I have disappointed Picard living in my bucket, and it's in a URL that I can access publicly because I've set when I uploaded it, I set the access control layer to public reads. Mm-hmm. And so I can share that URL, right? And maybe I store that URL somewhere in my database so that I have reference to that file that exists somewhere. So then when my page loads and I want to show the images that are in the bucket, I read from the database the list of uploads that I've uploaded in the past. I grab that URL. It's a URL for the object storage, publicly readable. I put it on the page as the image source, and it's going to go to the region where the object storage exists. It's going to find that resource, and it's going to download it.
Gotcha.
And the problem here, you can guess where I'm going with this, right?
No.
Tell
me the problem.
Well, the problem is it's deployed to one region in the world, and I build my applications to be worldwide, baby. Right?
Okay. This is one of those things where, like, all right, I understand, like, fundamentally that accessing that same URL from a different region would be less performant, yes, but it is still accessible. So
Yes.
this becomes like this is no longer a problem of whether or not it will work. This
Yes.
becomes a problem of like
It's a problem of scale,
exactly.
which was the previous problem as well of writing to disk on the server.
Yes. Right.
Right. So we're like slowly moving up. I don't want to say moving up the chain of experience or whatever, but we're slowly getting to more and more abstracted topics, right?
Right.
So now we're talking, and I think we'll probably sort of wrap it up soon. But now we're talking about users in Tokyo and Toledo and Toronto all trying to look at the same image. And one of those users is going to have a good experience and the other two are going to have to wait a while for that image to download, right? It's going to slow everything down, which is unnecessary because we have available CDNs. What's a CDN? You got this. No?
Like
Yes?
the actual definite, like, do you want me to describe how it works? It's a content delivery network.
Yeah.
Right.
Which means
it delivers content.
Nailed it.
It's a network
it's
as well.
It's a network that. Okay.
So these are things that are typically like a performance enhancer, but not like steroids. It's a different thing. They make content or internet bits available close to the person requesting it is usually like their performance benefit.
Yeah. So essentially what we can do is instead of having that file in one place in the bucket, we can route traffic through a content delivery network so that when a user goes to our application and loads the HTML and the HTML contains the path or the URL for an image, instead of pointing that URL to the object storage location, we can say, hey, image, go and get the URL that passes through my CDN, and I will configure my CDN to then grab that information from the object storage. And the first time a user does this in Tokyo, it's going to take a while because it has to go through the CDN, and then it has to go to the object storage location, has to grab the image, and then it has to send that back, and then display it on the page.
But after that,
every other user in Tokyo is going to go to that same URL, and the CDN is going to say, "Oh, I've already got a copy of that," because the CDN exists all over the world. That's one thing that we didn't mention is that, like, yeah, it's a network, but if we look at the Akamai CDN again, Akamai has 300,000 servers around the world. I don't know how many points of presence that is, but it's like, I don't know, in the several thousands. Yeah. So
that's a lot.
Yeah. So in several thousand cities around the world, like in physical locations around the world, there are tens of thousands of servers running. And those servers are going to, or the internet is going to route traffic through that asks for that URL through that server in whatever city you're in, usually within 5 miles of you, usually. And it's going to route traffic through that server, and then if it needs to, it's going to go back all the way to the object storage URL, grab the image, bring it back to that location in your city, store a copy of it, and then give it to the user. And then for every other person in that city that requests that same image, they're just going to go down the street to the CDN location, grab the image, and get it back almost immediately.
But that's like a really centralized paradigm, right? Now, let's do this again, but completely decentralized.
Do not say IPFS. What do you? Stop it.
This is one of those use cases that I'm absolutely pulling your leg. Like this is one of those use cases where a decentralized system starts to kind of fall apart, and where like centralized infrastructure and the way that we've I don't know, like built the internet and most things that work really well, um, they just work really well.
I mean, yeah, like this service, this works, and it's like, I mean,
It's
we're
great.
talking. You get so I did some tests, uh, and it was like almost a full second difference. Like loading an image, I loaded it in Frankfurt, Germany, I think. Same image. First request takes a while because it doesn't exist in Frankfurt yet. But once it's in the CDN, compared to going directly to object storage, 0.9 seconds. Through the CDN, 0.3 seconds. Or
Nice.
no, sorry. Yeah, it was something like that. Right. So that is significant, and we're talking for every image, for every static asset. If we're talking about CSS, if we're talking about JavaScript, and when the page builds, when you request an HTML page, it's going to build one part at a time, and when it comes across a CSS file, that's a render blocking resource. So the browser is going to go and grab that CSS and download it and parse it, or uh, download it before it moves on to the next line. And if you have another CSS file, it's going to go get that. And then if you have JavaScript, it's going to go and get that. So if you put all of these assets as close to the user as possible, we're talking about blocking time within, tens of milliseconds instead of full seconds.
Or you could just write all of your style tags in your HTML document.
You could. Yeah, you could. Yeah. Then you don't get caching. And that's a whole other story.
That's the HTML is cache, right?
It depends.
Or if you use your JavaScript to write style tags in the HTML document on the client.
There you go.
Yeah, now we're in CSS and JS land, and that's like a whole terrible argument that nobody wants to have.
Yeah.
Anyway.
So anyway, that's basically what I've been working on this whole series, videos I'm creating and content and blog posts, and we can kind of wrap it up there. There is one more thing that I'm not sure if it's going to get into this series. One is when you're dealing with file uploads, how do you deal with malware? And well, actually, no, there's two more things that I want to cover. One is more image optimization stuff. Like if we're talking about images specifically, when a file is uploaded and you want to store that, you might want to do some more cost assessment and resize the image and optimize it and remove a bunch of unnecessary data, like information about the image that is not actually impacting the visual representation of the image,
or stuff that could be a security vulnerability if it winds up on Twitter.
So you can do that when on the server side. There's a package called Sharp, right? And essentially what you may want to do is not just resize the image to whatever size it needs to be and optimize it and whatever. You may also want to make multiple copies of it, because eventually on the client side, you may want to serve images using source set attributes that can give a hint to the browser of what size the device is, and based on the size of the device can serve the smallest image. You may also want to do transformations, like transform a JPEG into WebP, and that's going to potentially be a smaller file size. And now we're talking about all of these big infrastructure considerations, because now all of these files need to live inside of object storage, and all of these need to be stored in the database and have a record of where they exist and what files there are. And now all of these are going to be stored on the CDN and optimized. So there's that. I will say, once again, it's really interesting to have services that can actually do that for you. I know that Akamai has one. I think Cloudinary is another one. Yep. And you can basically take all, I wrote a blog post just on that. And it's like, take all of the work that it takes to make actual responsive and like all the responsible images, and just like go back to just writing an image tag with the URL. Like that's really nice. And then the other thing is, yeah, like you said, malware. And yeah, that's another thing you have to consider. I think that there's something called, in Node.js, there's a package called ClamScan, which sounds worse than it is. It sounds like It's like, it sounds like a node package for OBGYNs.
Yeah, it sounds deeply inappropriate.
Yeah, but it's not. It's based off of a Linux tool called Clam AV, which is an antivirus. It's like the most popular antivirus tool for Linux operating systems.
I thought
So
the benefit of
basically,
Linux is you didn't need antivirus because nobody writes viruses for Linux.
yep, which is why you have Clam AV. It's, you know, just, yeah, it's just there so that we have packages called Clam Scan.
Gross.
So anyway, you can use that, and then there's other services like web application firewalls or something that you can put in front of file uploads. And anyway, all of this, we're kind of running up on time here, but all of this I hope was interesting and coherent enough to say that, man, you start with something that is as small as just, you know, we started with HTML and then moved to JavaScript and then to Node and then to object storage and then to CDNs and then to image optimization and then to malware scans and just like boom, 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 you know? So it's been
all to just have a little Picard image.
Yeah. You know what? We'll just stay with Gravatar.
Gravatar's looking better and better.
Yeah. No, it's cool though. I've like really been enjoying this deep dive stuff. And like, you know, talking about streams and buffers and like pipes and all this stuff that
streams, buffers, chunks, all of that on their own are like warrant their own deep dive.
Yeah. So, all right, let's finish up with how was that? How did I do as far as like communicating things coherently? And do you have any questions or comments or anything you want to add?
No questions that aren't just like a rabbit hole unto themselves. Like I think the overall big picture here is very well communicated and clear. But it also does a very good job of putting out caution and warnings, where I think like you had mentioned the pat answer of how do I upload an image and how do I like connect it to service. You describe reasons that you don't like that particular approach of like, we will just pull the URL from S3 and forward that onto the client and like have the client deal with it. Like there are very distinct and real disadvantages to that that people should consider.
Yeah.
You know,
I mean, you know, we don't even get into the fact that serving files directly from an object storage is a different domain, and there's performance considerations for serving cross-domain resources.
Right.
And when you set up your CDN, you can map it through your domain at like a subpath, or you can use a subdomain, and even that is a consideration you have to make on whether, you know, you want the browser to have to go off and do the TLS handshake again and the DNS lookup and like all this. So
there's some there for sure.
There's what?
There's some there.
There's some there. I don't know what that means. But all right, let's wrap it up then. Maybe maybe that stuff becomes another show. But so
there's a part of the show where we make like general recommendations and give accolades to like unrelated products or services. We have not officially named this, but I think that's pretty good.
What is?
General recommendations and accolades for unrelated products or services.
Yeah, it rolls off the tongue.
Just real smooth there, right?
Yeah.
Do you have any of those?
Yes, I do. Let's see. I have a pretty simple one, actually. I'm going to hold it up to the screen so that you can see it, but I'm going to do my best to describe it. I have gotten a credit card holder that kind of sticks to the back of my phone.
I thought you had broken your phone screen.
No. This is the back of the phone. Okay. And I'm actually going to do two shouts out that are kind of related. So normally, for a while, I was like, I always had my wallet in my pants, and I went to a conference and someone was giving out swag that was like their logo on one of these. So I was like, all right, I'll stick it on my phone and check it out. And I fell in love with it because I'll have my driver's license and my credit card, and just like I can just go out, and for the most part, I don't need a wallet anymore. I just need to take my phone.
Yeah.
And I also, there's this other little thing sitting in the back of this credit card holder that is a little metal card. And this is the second thing I want to shout out, which is a phone holder, a magnetic phone holder for your car. So I have this little metal plate.
It's like an attachment plate.
Yes, I have a metal plate, which normally you can like glue to the back of your phone, but I don't want to do that.
Yeah.
So I just stick this little metal plate in my credit card holder, and then I have a little metal plate that can magnetize to my dashboard phone holder, which is a magnet itself, and it's super strong. And I'll see if I have the actual brand that I'll throw in the show notes that I'm pretty happy with.
Okay.
Because then you just take your phone, you just snap it on, and you just pull it off, and you don't have to deal with like grabby things or like whatever, like just phone holder things.
Yeah, just a
magnet. It's great.
Just adding some Gauss to your life.
Yes, it's good.
Mm-hmm. That's cool. Yeah, like I have been using a relatively thin like front pocket wallet for a long time. But since I've started using what is it, like Apple Pay, like one of those like cell phone based payment schemes, like any of them do the same thing. I don't bring my wallet with me a lot of places. Like I just don't, like I don't necessarily want ID on me all the time. And if I don't have to, I won't.
What about when you drive?
I do bring it with me when I drive.
Okay.
But
sure you do.
I ride a bike a lot of places.
Yeah.
Like I don't have to drive a lot, and that's a great life to live, honestly. I just wish it was because we had like sufficient public transportation.
Yeah.
But we don't have that in San Diego.
No.
I did see somebody recently overlay the London tube system, like the London Underground system, over San Diego. And like, dude, it reaches all the way out to where I'm at. Like, I'm not central, like downtown San Diego person, but it reaches all the way out here. It really put into perspective, like, how bad our public transit is.
Yeah. It's bad.
It could have been a thing. Anyway, my recommendation or accolade, somewhat related to this, and it's like get a bike fit. If you've been listening to the show or are aware of me in general, I like to ride bikes. Doing that in an uncomfortable position or on a bike that doesn't fit you well can cause all sorts of problems. And like I'm training for races this year. I'm doing some like moderately like long distance races, like 70, 80, 100 miles. That gets real bad real fast if you're not in a good position. And so like if you're interested in getting into cycling or anything like that, if you want to like do mountain biking is a little bit different. If you're looking to like get into that, it's less fit intensive, mostly because you're not you should like doing the kind of distance and power that you are on like a road bike or a gravel bike, but still worth getting a general fit so you're not really hurting like your knees or your back. So I think getting a fit, like look up local fitters because it's got to be somebody close to you. Like giving a recommendation for somebody in San Diego doesn't make a whole lot of sense because I don't know what our listener base is here. But
yeah, I got you.
Yeah.
Man, I went to the bike shop down the street to get a fit, and the guy said he doesn't do it. Apparently, it's like a kind of specialized thing.
That's true. I feel like are you making like pun jokes right now, or are you being serious?
No, is there a joke in there?
It's a specialized thing. The shop down the street doesn't do it. Like, I don't know. Like there's this specialized bike brand, but bike? Yeah, okay, I don't know.
No puns.
Okay. Yeah, yeah. It is like a specialty where I think like seeing somebody who does bike fits on a regular basis is a good thing. It's a skill that somebody develops, like an eye that they can. There are like systems with lasers and shit that like don't get too crazy and overkill unless you're a professional athlete, but like make sure you're in the ballpark of like a good set of numbers for you that doesn't hurt you over time.
Yeah. Yeah, good call. Cool. Well, that's the show. Thanks again, Grant, for taking the time and putting up with my long garbled nonsense of file uploads.
For sure. No, I learned a lot. It's rad.
Good. Cool. Yeah, and thank you, listener, for hanging out with us. And yeah, if you like the show and you want to help us out, a review goes a long way. I think we only have one of those so far. But yeah, well, actually, I haven't checked in a while. But yeah, leave us a review and let us know or share it with some people. We would really, really appreciate that. And until next time, that's it.
I want to have a sign-off line.
That's it. That's your sign-off.
That's it. Go away.
I thought it was usually like, bye.
Bye. Yeah, I do. But that's what I say to everybody when I'm going away.
Yeah. All right. Actually, level 80 dev is here. So that's going to be the end of the podcast. Level 80 dev, thanks for hanging out. If you have any comments or questions for this like post-show section, we always like to give our streamers or our stream watchers a little bit of streamies, little extra time to say hey and get the live show benefits.
Hopefully you don't have chunks in your stream.
Hopefully you do. Yo, Brent, what's up? Been lurking, huh? Did you stick around for the show? Did you check it out? Enjoy it? Hate it? Any questions? Cool. Well, all right. In that case, I think we're gonna go, and you know where to catch the show. Hopefully, it'll come out the edited version if you want to listen to it again or catch something you missed. Yeah. Cool. Well, Grant, thank you. Level 80 B1, thank you all, and we'll be on again at some point with this very irregular show. We should eat more prunes.
That's like an oddly very personal suggestion.
No, because it would make the show more. It would keep us more regular.
I don't. Yeah, I am.
All right. All right. We'll leave it at that. See you later, streamers or stream watchers.
Streamies.
Streamies.
You are the streamer.
Yes.